So are you teaching at the Minor Institute in Washington? Mm-hmm. Minor 2? I haven't seen it since they rebuilt it.
Anyone besides Zeno back? Okay. Wait. Thank you so much for asking so many questions. You know, I really appreciate it. Okay, that's 4. Awesome, we got everybody. And just as a reminder, people other than Zeno can ask pretty arbitrary questions, even if they're on text. I do actually like questions. So, we touched very briefly a little while ago on programming for the TPM and how hard it can be. And I want to go into now a little bit more of the what and the why. This is not going to be a programming class today. 2 reasons for that. The first of which is when I did the survey for what people wanted out of a TPM class, not a single person said, yes, we would like to actually do hands-on programming for TPM, so you're not getting any. The second is that this is really worthy of a class in and of itself. Quite possibly 2 days just on programming the TPM, because TPMs are finicky, getting this code working is a pain in the neck, and there's a lot of complexity here. So what I'm going to be talking about now is really high level, what should you expect, why should you care, what are the different approaches, and where to go for more information, in as much as that is actually a possible thing to do, which is less than we would like. So why programming? Because the first question that I get asked once people are convinced that TPMs are neat is, great, where can I go buy products that use it? And the answer is you pretty much can't. Very few vendors have started doing even basic TPM integration because nobody's asking for it yet. And nobody's asking for it yet because they can't buy it yet. Because so, you know, it's not realistic, it's just research work. There are a few isolated products that do provide support. Things like Microsoft Global Utility for turning on BitLocker. There are some open source applications that tend to be very specialized, but they provide support in the sense of you can install them and run them, not the sense of what you want to debugging help. And they're really not designed for large enterprises. And there are a couple of vendors, or there's one vendor in particular, that does in fact claim to do widespread TPM support. That's basically their business model. It's called Wave Systems. And you basically hire them to set everything up in your enterprise, and they've got a kind of mixed reputation. So in general today, if you want to use TPMs, you've really got 2 choices. The first choice is build it yourself, and the second choice is convince your vendor to build it yourself and add it on, which means that programming the TPM is unfortunately today a necessary skill set, and it's not an intuitive one. So where we do have today in a little more detail, there's a lot of open source work, in part because that's where all the researchers are. So IBM has done a lot over the years. Most notably, they've got their TPM tools package, which can be easily installed in your favorite variety of Linux if it's got a standard package management system. You know, it exists on Fedora, it exists on Ubuntu and Debian. I'll be honest, I haven't looked at like Gentoo or SUSE, but you know, if you use weird Linuxes, you can do what you like. The thing about TPM tools is it does provide handy-dandy command line utilities. I have cited this in a few cases when I was talking about like how do you take ownership. I said on Linux you can just run TPM take ownership if you've got TPM tools installed. Very, very convenient for what it supports. Doesn't support attestation. It's really designed for getting your local data protection up and running. And unfortunately, I have heard mixed rumors that this may be an orphaned package. Somebody should really pick this up again because it would be really a shame to lose it. But there's basically one guy at IBM named Ken Goldman who does all of IBM's TPM support. And Ken has been a little busy, and I suspect he's decided he doesn't want to keep it up all the time. So I think it's lost its maintainer. There's a whole bunch going on in Europe. There's an OpenTC initiative there for open trusted computing. They mostly spin off little tiny research prototypes. It's a bunch of universities. Every so often a grad student comes along and says, my master's thesis is going to be Java and the TPM and what have you. Most of these show up, they get a little bit of support, and then they vanish again. Yeah, there's a university in Italy that's trying to do programming tools for Windows for the TPM. It's about what you'd expect for research, some grad student's project, which is to say, in some places it works, it's a little buggy, it hasn't exactly been comprehensively tested. The Thunderbird integration, it does exist on the Linux side. There's this wonderful thing called tboot, which is a bootloader variation. So grub is the standard Linux bootloader. tboot, or trusted grub, is a version of grub that has extra TPM compatibility and some very nice features. If you set up trusted grub, not only will it measure not only your bootloader but your Linux kernel, it will measure the kernel options. You can actually configure it to measure arbitrary files on your file system and store them in PCR. Pretty handy if you want to do things like, are my libraries in good shape? Is my core utilities in good shape? Unfortunately, tboot is based on the previous version of grub, not the current version of grub. And by the way, we did mention you're replacing your bootloader, so this is not exactly the sort of operation that Joe Schmo, who kind of sort of it's Linux. I think you can run Windows with grub, but I have no idea how you replace your bootloader on Windows. And it really does require a minimum threshold of competence to do, and it's not quite my complete wish list. Sorry. tboot doesn't have my complete wish list for features. For example, you can measure arbitrary files into a PCR, but the way it does it is you have a file that contains the name of the file and the expected hash of the file. And if any of those don't match the actual hash that it produces, your machine won't boot. So it's not just measuring, it's doing enforcement, which is not always what you want. In fact, often isn't what you want. You can break your machine with it. Whoops. So there's a lot in the open source world that uses trusted computing, and some of it is actually fairly mature, but none of it is really designed for large-scale enterprise use. It's designed for the competent home tinkerer. So, oops. Microsoft is starting to get serious about TPM integration. Windows XP had no TPM support natively. Windows Vista had a few commands that you could run. Windows 7 actually does have a TPM driver. We'll get to some of the downsides of that in a moment. And Windows 7 does in fact actually have BitLocker support. Which company? So the question was company called what? I don't actually remember what I just said, so I need a little more detail. Byte arrays are being produced by a company. I don't think so. Now I wonder what I said that may have sounded like that, so I can clarify.
I know, that's just because that doesn't sound familiar to me.
Yeah. Sorry. So Microsoft is now actually with Windows 7 supporting the full spectrum of TPM commands. You can actually turn on and off access to the TPM in the Windows 7 registry. You will be very surprised if you try and use the TPM on Windows 7 without doing this. And you can turn on and off access to individual commands, mostly. And the intent there is they are actually trying to support BitLocker with TPM support. So you can do hard drive encryption with hardware protection. They do now have a TPM provisioning tool that is, if you search for TPM on a Windows 7 machine, it'll pop up a little utility. You double-click the utility, it asks you for a password, it does some magic, it reboots your machine, and congratulations, you've got a provisioned TPM. We have heard rumors that this provisions your TPM in such a way you won't be able to use anything else. We have not actually tested this, but we really wouldn't recommend using it anyway because you are now trusting Windows. And let me be clear here, I'm a Linux user. I consider Microsoft to be extremely sketchy, and pretty much all Windows machines to be inherently untrustworthy. So feel free to take this with arbitrary grains of salt. In general, letting Windows establish your trust in your hardware really does not meet my security requirements at all. And as I said, there's this company called Wave Software that does do enterprise TPM integration. You pay them a whole lot of money, and they provision your TPM. They're the ones who did the very publicized PricewaterhouseCoopers rollout, where the TPM is basically acting as a smart card for all of the individuals. But you can't just walk up to them and say, hi, I'd like to buy your software and install it. It's much more of an enterprise support contract, from what I best understand it. So, you've decided that the existing options do not meet your needs, almost certainly. So you've decided you need to program something new to get TPM support. There's basically two approaches. The first is the Trusted Software Stack, better known as the TSS. This is a high level, for definitions of high that mostly mean it's not assembler, API for the TPM. It does some of its own complexity management. It manages memory for you. It manages keys for you. It has been implemented. Trousers on Linux is actually pretty robust. And again, you can install it very easily on pretty much every Linux distribution. There's a Trousers package. There theoretically exist implementations for Windows. They are all either hard to find, buggy, or both, as far as we know. There is one called the Entru software stack. I think I may get to this in a moment. I'm sorry if I'm jumping ahead here, but I want to make sure I cover it. That was created by a company called Entru that got bought several years back. So for a while you could get the software stack from Entru. For a while you could get it for Dell. These days we're not sure where you can get it or if you can get it. And that one was designed for Windows XP. I've heard reports that people have gotten it working on Windows 7, but it is a port, which means there may be some unpredictability there. You can also code at what I call the driver level. This is not really a technical term. It's more descriptive. Where, remember all those commands I was just showing you with those, this takes 4 bytes of a tag and 5 bytes of an ordinal? Well, you can just send that to the TPM, get the byte arrays back, and interpret it, or do something close to it. This is what Flickr uses. Flickr is all about the low level, there's nothing turned on. You're not expected to have something as gigantic as the TSS there, so if you're coding at, or you know, if you want your BIOS or your bootloader to use the TPM, you're going to be coding at this level. So, byte arrays going back and forth. In Windows 7, there is something called the Trusted Base Services, and this really is supposed to be a driver that passes data from the user to the TPM and back. We have heard reports that this does not always work. It appears to be buggy. So there are trade-offs here. The TSS does let you integrate much more easily with most applications. You've got some handy C API calls. You don't have to worry about assembling byte strings, which is very difficult to debug. It does manage things like authorization sessions for you. Remember how I said I don't even bother trying to pay attention to the authorization sessions most of the time because they're ridiculously complicated? It hides the vast majority of that. Similarly, if you use the TSS to create keys, it has its own key store that manages them for you. And very conveniently, perhaps the most valuable thing about the TSS is there's actually a book on how to program for it. It's not the perfect book, and some of the example code has been known to segfault, but there is a book that does explain some things about how to use the TSS, which pretty much by definition makes it the best documented piece of TPM utility anything. Also, at the driver level, there are some other advantages. The TPM specification is tremendously complicated, as you have probably just noticed. Compared to the TSS spec, it is tremendously well defined. The TSS spec is from the TCG. It is only a few hundred pages, but it is not nearly as concise or specific as the TPM spec is, and unlike the TPM, it doesn't have the equivalent of the design principles to the same degree. The TSS does not document very well at all a lot of its whys. It's got multiple levels. So there's the TSPI level and the like TCS level. I don't even remember the details, but basically there's a level that is meant to be, you know, sort of intended for drivers or remote access, and another level that's meant for local applications and different. The same command can be implemented at multiple levels with different arguments, but not all commands are implemented at a given level, which means that trying to figure out what to do if you want to combine command A at level A or at level X and command B at level Y is really not intuitive and is currently giving me headaches. So compared to that, the driver level coding is actually pretty straightforward. You've got a very clear idea of what you're doing. If you are comfortable working at a very low level, and for very simple applications, if I just want to do, I create a key, I sign with that key. There's very little overhead at the driver level compared to the TSS, which has all of this memory management and key management, authorization, session management. Now the cons are pretty significant in both cases. See previous note about the TSS spec is very, very complicated. It is much less intuitive than the TPM, and that's saying something. With those multiple abstraction levels, how do you combine them? Which one do you use? Really not clear. The stack's pretty big. You've got to have a daemon running in the background on Linux that does, in fact, take up some space. And see that key store. And debugging for the TSS is rather a pain in the neck because you have all of the error codes coming back from the TPM, not all of which are clear, plus all of the error codes coming out of the TSS stack itself, not all of which are clear. Sometimes it passes things through, sometimes it doesn't. It's a pain in the neck. At the driver level, you have none of the back-end support that the TSS offers you. So you have to manage all of those, you know how I said there's that overhead in each command below those double lines where there's a nonce being passed back and forth, you've got authorization sessions being continued or not. That's very complicated, it's very fragile, and if you're programming the driver level, you actually have to deal with all of it. If you're doing one-off commands with no authorization, that's easy. But once you start getting into commands that need authorization, let alone things like DAA, where you've got an authorization session that lasts over 27 versions of the same command with different arguments, that's not something you want to be programming at the driver level if you have any choice whatsoever. Also, unless you are actually comfortable working at the level of byte arrays, which most people, to be perfectly honest, are not, it's extremely difficult to read, extremely difficult to debug, and errors are not exactly going to jump out at you if you happen to have the wrong number of bytes in a tag. The only documentation for it is the spec. You know, maybe you can find somebody's driver who uses as an example, but it's not like anyone's writing books on how to program at this level. And funny, debugging is extremely difficult. You may notice that error is that problem is on both lists. That's there for a reason. Programming for the TPM is a pain in the neck. To make matters more difficult, some TPMs are buggy. Was that your code that's causing a problem, or was it the TPM? I've hit that. I spent a week and a half on a particular machine trying to figure out why my quote code wasn't working. Finally went to a different machine, and it worked immediately. It turned out that that particular machine had a TPM where most operations worked, but every time you asked it for a quote, it gave you back a 0-byte response. Whoops.
So what do you do with that?
And in that particular case, I threw out the machine. We don't have a good answer. We don't have statistics for how frequently TPMs fail. This is one of the reasons that one of the things that's on our research project list is we're trying to get a hold of the TPM compliance tests that the TCG runs.
Okay.
in the hopes of using them for a project whose sole purpose is run this on as many machines as possible and see if most TPMs do pass compliance checking, what's actually checked in compliance checking. Now, having seen that webpage today that said only Infineon even bothers to run it, well, it doesn't even matter what's in it. But we'd like to get some sense of what the failure numbers are, and we don't have those yet. TPM failure is not a design flaw or implementation flaw. In general, the TPM failures that we're seeing certainly appear to be implementation flaws. If that answers your question. We don't have numbers. A design flaw we would expect to see, frankly, from analyzing the spec. We have not been comprehensive at that, but we've been steadily increasing the amount of spec we're looking at. We have not so far found much in the way of design flaws, except for that previously mentioned the SHA-1 collision attack that turned out to be a problem because they had not been completely careful about how they designed the sign structure. That said, there may be some lurking out there that we haven't seen. When we talk about TPMs failing, it is all of the cases that I can think of are because somewhere some TPM deviated from the spec. In some cases, it's been this one command fails. In a couple of cases, it has turned out that they failed to implement a sanity check in such a way that code that did something unexpected actually managed, in at least one case, managed to brick a TPM.
So is there a way to kind of backtrack on that, figure out from that one desktop or laptop the TPM came from its manufacturer?
Yes.
And then you can assume that everything in that product line may have that same.
We can certainly backtrack to the manufacturer.
Yeah.
How much it is a universal failure versus it's a $1 chip that nobody cares about, so they didn't implement any quality testing. So the chances that every Broadcom TPM fail is buggy simply because one was buggy. That doesn't actually necessarily hold, but it certainly means that if we start seeing a pattern, we want to be very careful. And we are looking to get those numbers. We don't have them now yet. So yes, what we've seen so far are implementation flaws. They have been, in the cases where they were really critical, we have reported them. But as I said, we're well into the anecdata stage. We have no real data, and that's one of the things that we and several other people would like to have someday. The TCG doesn't even know what the failure rates of TPMs are. So drilling down a little bit into both of these, and as I said, this is a little bit. I'm going to give you a high-level idea of what programming for these looks like, and if we really want to get into that, you let me know, and we'll teach you another course on how to do it, because this is not something we can cover reasonably in an afternoon in enough level to make you comfortable doing anything. So the Trusted Software Stack has its own spec from the TCG. You can get it on the on the TCG's website. And the intent of the TSS is that this is the standard interface to the TPM. This is what everybody will use to talk to the TPM. And when I talk about the TSS, I'm really referring to two different pieces. There's the API, which there is actually a standard API. Instead of C header files, that is the definition of the TSS interface is those header files. You can download the header files from the TCG. And the spec actually really describes that API. And there's also a back-end driver, which in Linux it's called TCSD. I don't actually know what TCSD stands for offhand. The last D is daemon. I'd have to actually look up what the first three are for. Trusted Computing Stack or something, probably. There's also a back-end driver that is inherently part of the TSS, which deals with exporting that API, handling the TPM communications, and doing a bunch of the management that is inherent to the TSS. Because you remember I said the TSS manages authentication or authorization sessions, manages key storage. So there's a lot going on in the back end of the TSS. So implementing one of these is not trivial. It does maintain quite a bit of state. The big working implementation is Trousers. See, it exists on Linux. It has been ported to Windows 7 by a bunch of Italians. It's about what you'd expect from a bunch of people doing this as master's thesis. You can put that Trousers package on your machine in pretty much every standard Linux distro. There's also the Entru stack, which is a TSS implementation. If you can find it, which is often difficult. I've heard some people manage to do it pretty easily. They then told me how to find it and we couldn't replicate it. So comes and goes. Windows XP is actually pretty solid. Windows 7, it has been ported but not by Entru, because Entru doesn't exist. Exactly. Sam says he could never find it. I've never found it. There's multiple versions floating around because there was Entru, and then Entru handed it off to Dell, and then Entru was bought by Wave. So even if you manage to find it, the version actually matters. The early versions were actually pretty buggy. Some of the newer ones are better. Yes, there is a version that comes bundled with his if you actually get your hands on host integrity at startup. I don't know which version it is, but I do know that that exists, and that is the version that I have heard has been ported to Windows 7. But as far as I know, the folks who ported it to Windows 7, ported it to Windows 7 to use his. That supposedly works. It's not like it's been comprehensively tested, and as far as I know, they're running in 32-bit mode. So neither of these is perfect. Bug reports do come in on a pretty regular basis, but as such software goes, these are both pretty reliable. I would not worry too much about building commercial software on either Trousers or Entru from what I have heard, as long as you're willing to put up with the occasional bug, and in Trousers' case, potentially fix it yourself. So authorization sessions, when you use the TSS, you can basically say, associate a secret with a resource. It will do authorization for you. It will take your password. In some cases, depending on your flags, it will even do pop-up little graphical password entry support. And that means that actually doing things like making sure that you've got the right password for your key is very straightforward, in as much as anything in TSS is very straightforward, which is not very, but it's doable. It also does have its own internal key store. It will make sure that when you say, load a bunch of keys, even though the TPM has limited key storage, it will do key swapping if it needs to make sure that from your software's perspective, there are keys that are loaded, and they'll go in and out of the TPM as needed. Realistically, this is not a feature most people need. They don't have enough TPM keys to matter. In at least some implementations, which is that I have heard reports of this working on Linux, when you create a key, it will store the key in an internal store. You can keep using the key handle over time, even over reboots of the machine. That really shocked me, because I hadn't thought that was the case. But apparently it is, which is tremendously convenient if you don't want to handle everything. I'm paranoid. I don't rely on it, but it's there. It's a feature, and if somebody actually dug down to make sure, find out more about how it worked, this is the sort of thing that when you're programming for an enterprise is tremendously helpful, because you don't have to worry about all the details that it hides them. This is a partial implementation of one function in the TSS. If I were going to be doing this in any font, to contain the complete process, it would take up several pages of slides in a font you couldn't read. So this is just enough to give you a taste, a tiny, tiny taste of what coding with the TSS looks like. So pretty much every TSS command starts with this concept of TSPI, context create. The TSS has contexts. You're going to ask what a context is, and I'm not going to be able to tell you. It's this thing the TSS uses all over the place. You can think of these sort of as a session. Why they call them contexts and what exactly they do, I don't know. There's a book, it might tell you. I don't remember it telling me when I read it, but it might. You have to connect to the context. I'm not really sure why. You have to get an object for the TPM that you will then use to say, I'm addressing the TPM, which is always one of those funny cases where there's only one TPM per machine. Why do you need to get a separate handle for it? I don't know, but you do. Loading keys, there's multiple ways to load a key. You can load it by UUID and you can load it by blob. When we say load key by UUID, you're basically handing in a universal identifier. This is particularly useful if you're using something like the SRK. It's in a known location in memory. You always know where to look for it. But remember how I said it has its own key store? When you create a key, you can establish a UUID for it. And then later on, you can address it by UUID. On the other hand, if you're getting a key blob back, storing it on disk, you use the load key by blob to pull that key off. You pretty much start almost every TPM command with one of these load key procedures because after all, without a key, very few TPM commands don't use a key for something. Of course, when you use a key, you need to make sure you've got the authorization value for the key. So we deal with these things called policies, where you create a policy object and then you associate things like passwords with it. And then after that, you can start getting into little details, like if you're going to actually run a create key object, you have to start by creating all of the object information about the key that you're going to create. And this is just getting started. This is not complete. I cut pieces out. It's not intuitive.
And this all has to be done command line?
No, this is a C program.
This is the program.
This is a C program.
I mean, it seems that it could be prone crazy to human error.
There's a lot of potential human error here. You can see this runs together a lot.
Right.
No, but this is C.
Yeah.
You do get some debugging support here. If you want to use GDB on it, you can. All of those result equals.
Yeah.
That is, it will run that line, and then you will get back a result, which is either a TPM error or a TSS error or success.
I was just going to ask
So
that. Okay.
what I have cut out from here is every single one of these lines in the original code included, if not TSS success, print the error.
Oh, okay. Okay. Great.
So there's a lot of debugging support coming from TSS.
Yeah.
And you can pin down pretty easily if you're coding here where the error is, which line the error started in. Where you start running into problems is things like you've got all of these, get a policy object, set the criteria on the policy.
Yeah.
This is very straightforward with a key. I have a policy for the key. It starts getting really complicated when you're trying to say, I want to provide the owner password to this command for the TPM. This is my current debugging problem is I'm still trying to figure out how the heck to get capability to run.
Yeah.
And take the owner password so it has the right permissions.
Okay.
Because this is where the TSS is really not documented very well. It has a whole lot of commands that are listed, but the why of how you use them and the when you use them and how you use them together is where the TSS is not very well documented. Now, there is a book. Dave Challoner is the guy who wrote it. He actually was one of the people who designed the TSS spec. And it contains things like, this chunk of code was pulled out of Dave Challoner's example code. Okay. And so he will say things like, this is the header that pretty much every TSS code needs. And he doesn't always tell you exactly why, but he'll basically say, just cut and paste this into your program. And he talks a bit about things like, so you have a key that has an authorization value. Here's how you establish the authorization value for the key. It's got lots of example code in it. Some of the example code is buggy. I'll have to see if there are errata out. But for the most part, yes, it's mega complicated. If you're a C programmer, spend a couple of weeks on it. It starts to make a little more sense. The fact that it does its own memory management is actually what has thrown off several of the experienced C programmers that I know, because it apparently does so in a non-standard way. I am not an experienced C programmer. I'm a minimal C programmer, and I've got TSS code up and running. It's not actually that hard if you're doing simple things. Where you start running into problems is when you run into something where you don't have example code for it, what you want to do is not obvious, and what do you do next? Now, I want trying to get TPM to sign something with the TSS actually stumped me. Fine, that's not very complicated because I get one of those cases where the sign command was at abstraction level A, and the load key command was at abstraction level B. One of them had a key handle at abstraction level A, the other had a key handle at wanted a key handle at abstraction level B, and dropping A into B directly did not appear to do the right thing. So how am I supposed to translate these? It's probably simple and obvious if you know. How do I find out? Good question. I'm planning on emailing Dave Challenger.
Yeah.
Like, that's sad.
Yeah.
When the right answer is to email the guy that wrote the book.
Yeah.
That's sad. But it's there. So TSS is in many ways the fastest one to get started with because in addition to that book, and this is in your quick reference guide, you can search online. There are a set of slides from Dave Challenger. There's a set of example codes from Dave Challenger from an afternoon class he taught at the Trusted Infrastructure Workshop at Carnegie Mellon. I do actually highly recommend that if you want to play with using the TPM. It basically has everything from turn on the TPM up through get a little demo program working. And having seen that in action, that is the reason that I say if you want to learn how to program for the TPM, let's take 2 days. Because the 4-hour session that he tried it in, about half of the class managed to get the TPM up. And the demo program executing. Very few people got as far as writing their own code in that 4-hour window, in part because most people didn't come prepared for this. Their TPM wasn't turned on already. They need to take ownership. They need to install some packages. There's a lot of prerequisite work going on. So if I were going to do this as a class, realize I could set all of that up for you, but then you don't know what you're doing when you try and go home and do it yourself. So if there's interest in a TPM programming class, be aware how much overhead there is.
Yeah.
Now, if you're doing this for real, if you're doing this in an enterprise environment, you want to get a corporate development up and running.
Yeah.
Yes, there's a lot of overhead in getting started using the TSS, but once you've done that initial training, and I would pretty much allocate 2 to 3 weeks just to get somebody's feet under them for this, once you've got that, adding more is not usually that complicated. Every so often you run into a headache,
Yeah.
but fundamentally, this is the method that you are most likely to get an experienced C programmer up and running with. Now, not everybody likes that because, oh my gosh, the overhead. This is what I just suggested. See the book. See your sheet if you want to know the details. So some people strongly prefer the driver level code. This is the support for driver level coding is not nearly as coordinated as the TSS standard. Because there is a TSS standard, we've got implementations like Trousers. When it comes to the driver level programming, most of the implementations that are out there are either for very minimal environments, where you're really expecting to homebrew your own driver, because what do you have? You have very little going on. So all of the Flickr, there is example code from Flickr, which is actually what I'm going to show you in a moment, for, given that you're in the secure CPU mode, just talk directly to the TPM. Again, that's basically writing your own driver at that point. Windows 7 does have this native TBS support, which is theoretically a direct pass-through, but we've had reports that in some, but not all cases, it may modify your blobs. Debugging that's going to be a pain in the neck. But if you want to use direct driver level code, there's a very good chance you're basically going to be homebrewing your own driver or finding somebody's documentation of their driver that you can use. One thing that I don't mention here is that that TPM tools suite on Linux is actually direct TPM code. It was built before the TSS existed. I am so glad you were talking to Microsoft to get that fixed. I greatly look forward to that. Oh, perfect. Apparently Corey was sending out emails today. Hopefully this is a bug that will get fixed. I look forward to hearing a response because I'm half expecting the response to be that's deliberate and just not documented. I'm a skeptic, I'm sorry. But I will, if you do get a response back in either of those cases, please let me know so I can update these slides as soon as we have an answer. I will be delighted to issue erratas for this class, let me tell you.
So I have a question. So as far as TPMs on Windows machines or and Linux machines as well, are they on Linux?
TPM,
Linux is the operating.
Linux is the operating system. TPMs are on basically every user machine except Macs.
So
You
going
can
like
get
down
them-
to XP and starting at XP. Okay.
It's not even starting at XP. It's starting about 5 years ago.
Okay.
TPM started to be on pretty much everything.
Okay.
Servers are a little more erratic. Often TPMs are offered as an option on servers, and they are not always the default. Or even if they are the default, you can order one without. So if you are ordering a server, you will need to actually explicitly request a TPM. Your laptop that's sitting on your desk has a TPM in it.
Okay.
I can tell you that because it's Dell.
Yeah. Okay. Okay. Thank you.
Yep. So some of the most experienced driver-level coders that I know have in fact homebrewed their own driver because it was the way they felt was most convenient and most reliable. This may or may not be what your enterprise wants to do, but it may be the most reliable choice, unfortunately. So the problem with this is one thing about the driver-level code is I can get started programming for the TSS very quickly. With the driver-level code, there's not nearly as much infrastructure support for me getting started. That said, here's the basic process of coding at the driver level. You need to assemble your data structures based on the TPM structures spec. Here, have a bunch of bytes. You need to assemble your command blob based on the TPM's command spec. Again, assemble a bunch of bytes. Keep in mind, this is going to include all of your session information, all of your nonces. You send that blob to the TPM, you get it back, and then you start breaking apart the resulting set of bytes into certain data structures and overhead. You need to do your own sanity checking to make sure this is the response you were expecting, and then you can start interpreting your data structures, assuming that you did this for a reason. So in some ways, this is very straightforward, and in many ways, this is very complicated. Whether you think it's straightforward or complicated and annoying really depends on whether you are a very low-level. If you spend your time programming kernels and drivers, this is way more straightforward than the TSS because I have a spec that tells me what everything is supposed to be. On the other hand, if you are used to programming at a high level, or worse yet, you're used to programming in an object-oriented language like Java, where everything is very high level, you've got abstractions, you've got memory management support. This is a pain in the neck. So, which you prefer is in many ways a matter of personal taste on the part of your programmer. For myself, I use the TSS. I know somebody else who swears up and down that he will never touch the TSS with 10-foot pole. He likes his driver-level coding. And you know what? He's great at his job. He does wonderful stuff with it. There are some things that are way easier for me and some things that are way easier for him. He wants to whip together code that signs data. He can do it in an instant. When we start getting to the commands that require authorization sessions, I have a much easier time of it. But I've been beating my head for weeks on getting the TPM to sign things. So trade-offs. I mean, I haven't been putting much time into it, but it was not an afternoon. So just to give you an idea of what driver-level code looks like, and this is driver-level code written in C. So when I said that the previous API was in C, these are both in C, but you can see that we're looking much less at high-level, look, this is a command that is, TPM create key, and instead we're saying we've got a whole bunch of buffers with specific byte values in them. We've got to specify how long the bytes in our buffer are. We've got to transmit it to the driver, get it back, and now we've got this buffer that we're going to begin breaking apart byte by byte and interpreting. So, this is what part of what I mean by debugging is a pain in the neck here. If you mistype a C as a D, it's not exactly going to jump out at you the way, oops, I've got a pointer error might, or look, I've got a typo in a variable name. So, again, is this easier to understand or not? Good question. The only reason I know that this is TPM extend is because of the name of the function that I got it from. And that's part of the problem with the driver level code, is it's very straightforward to construct if you have the spec in hand, you're going to want to comment the heck out of this if any human being is meant to ever understand what you're doing.
I was just going to ask you that.
So, trade-offs. My own personal soapbox here. One of the things that I think this entire area desperately needs is something that is easy to use. A lot of the reason we're not seeing people adopt it is not only are there no commercial products, but the commercial, the vendors, even if they decided, yes, we'd like to support the TPM, the spin-up time and the difficulty of spinning up with these two things as our options for programming, really not very friendly. And we've heard, when I mentioned to the folks who wrote the TSS, I would say the complicated it is. The answer has generally been, the TPM is complicated, it supports lots of options, we need to be that complicated in order to make sure it's well supported. Now, I'm not sure I entirely believe it needs to be that complicated to be well supported, but they certainly have a reasonable argument that, yes, we have lots of flags, we have lots of switches we can throw. That said, for the vast majority of what most people and most applications want to do, we don't need all of the TPM commands. Most people, if we ignored the delegation commands, they wouldn't notice. Most people, if we ignored the certified migratable keys, wouldn't notice. Most of the time, we want to sign data. For that matter, we often don't need the full range of options. If we say all keys should be 2048 bits, then I can, if I'm willing as the person creating this API to make that choice, I can just not include key length as an option the user has to provide. There's a lot that I can hide behind an API that is basically best practices, where by doing so, I both keep the user from making a mistake and keep the user from having to think about it. So there's lots and lots of places in these specs that I probably can develop what amounts to the 90% solution, where most users will get everything they need with a very basic set. And at that point, advanced users with unusual applications can do the hard approach and brew their own. But if I want to build a browser that uses TPM keys to store its data and to sign certain things, all I need is a create key. Forget create key, here's the options. Give them a command, create signing key, create storage key. Sign, seal. So the other thing is, right now, if I'm going to use a TPM key, you have to load the key, then you have to use the key, you've got key blobs that you need to maintain. One of the things that I'd really like to see, is that I'm really surprised the TSS didn't do this, is make those actions atomic. Use this key to sign this data. Use this key to make this quote. Just hand it a blob and a command. There's no reason the user needs to think about the fact that that key needs to be loaded first. The user shouldn't need to think about the key handle or the UUID. There are ways we can do this that will make life a lot easier if somebody is willing to actually fund the development of my dream API here. Where the basic goal is, for the most part, and you folks have been very patient, not asked all that many questions, we can describe the TPM's functions at a level that most human beings can understand it without needing all of the nitty-gritty of the specs. There's no reason that we couldn't do an API that does the same thing for the vast majority of applications. So hopefully someday I'll find somebody with a lot of money to develop that, but in the meantime, we just hope. So the summary of programming today, we don't have any really good choices. The TSS is very overcomplicated, very high overhead. The driver level API is very complicated in the opposite direction and extremely low level. There are support architectures that do exist, but they're not universal. Linux is generally better than Windows. There's lots of room for improvement. There's lots of room for vendors if they want to shine and say, look, we provide TPM support and this is what we can give you, but it mostly doesn't exist today. So that's my little lightning summary of programming for the TPM. As I said, if you want resources, the TSS resources are listed on your quick reference sheet. And if you want resources for driver level programming, I'm sorry. Remember that piece where we gave you the tour of the stick. I'm sure you're delighted. Are there any questions about that?